Good evening, everyone. My name is Ken Chasen. I'm Senior Rabbi here at Leobeck Temple. On behalf of our synagogue president, Lloyd Segan, our board of trustees, I'm delighted to welcome you all here for an important evening of learning and conversation. We are, I would suggest, probably the ideal location for this conversation tonight. Located smack dab in the center of the Sepulveda Pass. And in order to get to our synagogue, sooner or later you have no choice but to either get on the 405 freeway or Sepulveda Boulevard or both. And that means that it is sometimes veritably impossible to get to our synagogue. And that means for all of you, I hope you enjoyed, I trust that you enjoyed combating that challenge yourselves at rush hour this evening for the purposes of participating tonight. So, this is a perfect preamble for the conversation that we'll have here this evening. Our congregation, not so surprisingly as a result of our location, has spent a little over 5 years in our community organizing work under the direction of our Vice President of Social Action, Eric Stockel. We have been working with city government officials, with Mayor Garcetti's office from the very beginning of his first term, with our county officials, with the MTA, and business interests up and down the Sepulveda Pass, the purpose of achieving advancements in public transportation. A number of important victories over the course of those years, most especially the victory of the passing of Measure M in 2016, which of course brought with it a host of important transportation advancements for our city. But over the course of the work that we've done, it has been our great good fortune to make relationships with important business leaders, entrepreneurial visionaries who have been able and willing to dream big when it comes to a transportation revolution that could transform the way we connect with one another, not only here in the city of Los Angeles, but throughout the country and even throughout the world. For us to be able to talk about that here this evening and to dream of a world where we can achieve those type of writ large victories, not only for our quality of life, but for the preservation of our natural resources, is a great, great honor. Delighted, therefore, to welcome our presenters this evening, the Boring Company, and all of you as our guests for an evening that I am sure will help all of us to be inspired about a future that could be bigger, better, and brighter for us all. It is my pleasure to introduce Jen from the Boring Company, who will introduce our panel for this evening.
Hey everyone. Thank you all for coming and for tuning into the live webcast. Elon and Steve are going to take us through the vision of the Boring Company. We're going to talk about our project in Los Angeles, and we're going to close with questions. With that, take it away, guys.
All right, so yeah, thanks for coming. So we're going to talk about what we're planning to do, answer whatever questions we can, and there's quite a lot of education I think that needs to be done with respect to what's possible with what is probably to be described as like personalized mass transit, effectively, and I mean there's some things that are conceptually quite different from other modes of transport. We think this is the only way that we can think of to address chronic traffic issues in major cities. Like almost every major city, and LA is, I mean, arguably the worst, but certainly among the worst in traffic. In fact, part of the reason we were late was we're stuck on the damn 405. I mean, that is like, yeah. But everyone's, almost every city in the world has severe traffic issues. And there really don't seem to be solutions that are anywhere around the corner, or like even that might work that I'm aware of. And I've been living in LA since 2002. In 16 years, it's like the 405 has gone, it varied between like the 7th and 8th level of hell. It's like sometimes 7, sometimes 8.
It is not improved.
Exactly. The point is that it's just not improved over all that time. And so, we're not suggesting that this is, it's the way that we think is probably the best way to solve the problem, but there may be ideas that others have. We're not suggesting this to the exclusion of other approaches, but it's the one that we think could work and is worth trying. So we'll tell you how we're going, how we're doing it. So there's the problem. Exactly. We're going to start with the problem statement. Soul-destroying traffic. There's a few ways to skin this cat. I don't think this is the problem with this is that there will be like zillions of these things flying all over the place, and inevitably somebody's not going to service their car properly, and they're going to drop a hubcap, and it's going to guillotine somebody. And it's going to be noisy with a lot of, it's like, I feel like a hurricane. I mean, can you imagine how much Air Force a little drone has, like one of the little drones, and these would just be huge by comparison. And so I think this is maybe I actually don't know any way to make the physics of this work just because of the sheer amount of wind force that has to occur in order to lift something that's carrying a person. You really can't even fly the quietest helicopter through neighborhoods without bothering people. So I think it's really hard to imagine going 3D up. So that if you can't go 3D up, or if it's unlikely that you can go 3D up, then what about going 3D down? That's the other direction. And you can go to very many levels down. So you could in theory, you could have like hundreds of levels of tunnel. And arbitrarily solve any level of traffic. So we often get this question of induced demand. Like if you add a tunnel or some new transport system, will demand then not just increase and we'll be back where we started? If you look at, say, the 405, you add a lane to the 405, you go through definitely in the worst level of hell while the lane's being constructed, and then when it's finished, it seems like it was hardly different. Okay, but the thing is that what's actually happening with highways is that the highways are at the actual outer limit of their capacity, and you're really just barely moving the needle in capacity. But for tunnels, you could have hundreds of lanes, and there's no real limit. In fact, the fundamental issue that we face is that so much of our life is 3D. You're in a tall building, or in a dense office environment, and then we go to this 2D plane of streets, and the consequences are obvious. You're losing an entire dimension, and everyone wants to go to and from the buildings at the same time. We sort of want to arrive at work at the same time and then leave around the same time. So then, obviously, you're going to get stuck in traffic. This is guaranteed. But if you can do hundreds of tunnels and you can have many small stations woven throughout the fabric of a city, you can actually, without even the city even appearing different, you could solve the transport problem. Because one of the other issues with, say, a subway tunnel, and by the way, I'm not against subways, it's just that it's just one of the challenges with subways is that when you've got very large stations, then you're going to put a lot of people will need to go to the station, come from the station, and it creates a lot of congestion around that station. You have to reserve real estate for the station, and it's very difficult to weave large stations into the fabric of a city. But if you have many small stations that are not much larger than a parking space, then you could really seamlessly integrate a new transport network into a city, and it wouldn't affect things in a bad way. And it's compared to an above ground system, or compared to a flying car, you don't have to worry about bad weather. You can't see it, hear it, feel it. You're not dividing communities with lanes. and we think we can make this really fun. Like, Steve was like,
Yeah, no, absolutely. These, you're right. You have to stay three-dimensional. Flying cars they don't reduce anxiety.
Right.
They don't really exist. While tunnels do exist and are very buildable, and it's all about building them better.
yeah, I mean, the thought experiment with flying cars, like you say, a helicopter with wheels. You know? Could always add wheels to a helicopter. But anyway, so the keys are we got to figure out how to tunnel fast, safely, and at a cost that's not crazy.
Can I give the cool speed facts for the snails and just to show
Yeah, exactly.
which
This is our little friend, little chum Gary, the snail.
the company mascot.
Yeah.
So just like order of magnitude, I mean, human walking speed is approximately 2 to 3 miles an hour. The fastest boring machine in the world is about 0.003 miles an hour. And a snail is about 0.03 miles an hour. So you have the boring machine, which is 10 times slower than the snail, which is 100 times slower than a human. So what Elon has challenged the company to do is at least beat the snail. And so hence our mascot.
Yeah, exactly. Yeah. It's not like this tunnel is going to be ripping through the neighborhoods. It'll be like, like a fish called Wanda.
Yeah.
Like when the, I don't know, like remember that scene with the steamroller. It's like, watch out, the tunnel's coming.
It's just a crazy image that if you take this and you put it on the ground and you put a boring machine, this thing will like pull ahead in a time lapse.
Like 10 times faster.
Yeah.
Yeah.
It's terrible.
Anyway, so we do want to be faster than a snail, which is way harder than it sounds. And then ultimately, if we could, like the dream would be to be maybe 1/10 walking speed, which would be, if we could be 0.3 miles an hour, that would be, wow, then you could get a mile done every, 3.3 hours.
Yeah. It'd be LA to San Fran in like a few weeks.
Yeah.
Exactly.
But you're still like 1/10 walking speed.
Yeah, it's still in like
you definitely
embarrassingly
run
slow.
away. You could crawl away from it with one arm.
Yeah.
Yeah. Like pretty thing. Not scary.
Yeah. I don't know if you want to talk about some of the ways we're doing it.
So some of the key things to make it go faster, you got to do continuous mining. So you got to drill continuously, and then put in the reinforcing segments while you're drilling. So typically, what happens right now is that you drill for a bit and then stop, and then you put in all the reinforcing segments. And that takes ages. In fact, it takes way longer to put in the reinforcing segments than it even takes to tunnel. So if we can just dig continuously and put in the reinforcing segments at the same time, that would be at really more than a doubling of speed, maybe a tripling or quadrupling of speed. For the in-house design for the boring machine, we've tripled the tunnel boring machine power, so it has 3 times as much power. We have, these are like a lot of things. This is really not like brain surgery or rocket science or something like that. So we're using like really first-rate engineering talent to solve problems that I think are pretty straightforward. Like one of the biggest challenges is how do you get all the dirt out? And it's really quite laborious to get the dirt out normally. So we've figured out designs to remove the dirt quickly, automate segment erection, and just in general, go faster. A lot of the time that's required for these boring machines is for laying tracks and for like really long power lines. So you can figure if you're like a mile-long tunnel or 2 mile-long tunnel, you need like a couple of miles of high-voltage cable, which is really big, heavy cable. Because the boring machines themselves are all electrically powered. But having 2 miles of high-voltage cable is pretty expensive, and you've got to keep laying out more cable. We want to make this more like a cordless drill. So it'll be using, like Tesla battery packs and whatever to drill, and then it can drill without you having to have this crazy cable behind it.
And the trying new things, while it's lighthearted, is actually it's actually rare in the United States. There's one school that specializes in mining, but in general, there's almost zero R&D in tunnels in America. Most of it's either in Japan or in Europe. So it's really, trying new things has actually been very helpful for us. There we go.
This is we made an electric locomotive. So we think this is the biggest electric, battery-powered locomotive to be precise. So electric battery-powered locomotive. It's actually just using some Model 3 motors and batteries to haul the rail muck cars. Are those like 250,000 pounds or something?
Yeah.
Yeah, it's like 250,000 pounds of muck of dirt on the rail cars.
Pulled by 2 electric motors and a battery pack.
Yeah. But the other tunnels at scale all use a diesel locomotive in a tunnel, which is kind of a crazy thing to do. You have all these diesel fumes, and it's dangerous and smelly, and you have poisonous fumes. But it's kind of a silly thing, but we think we're probably the first to use a battery electric locomotive.
Of that size.
Of that size, yeah.
And if you ever see the pictures, you can kind of see it up there, that enormous ventilation duct at the top. It's a 3-inch ventilation pipe, and it's solely there for before we made the electric Loki for the diesel Loki. You have this gigantic ventilation pipe, and the second you went to electric, you barely need that, which is great.
Yeah, exactly. So the vertical integration, we were creating our own concrete segments. And we're creating them on site using dirt that we dug out of the ground, which, again, may seem like an obvious thing, but this is almost never done. Or we're aware of a case where the concrete segments, the reinforcing segments, actually use dirt that's dug out of the hole. It's typically using some construction company far away, and then they bring in the construction in the concrete segments. But we actually just make the concrete segments on site at the start of the tunnel. And then we're making bricks out of the dirt, and these are bricks that are made by compressing the dirt at extremely high pressures, adding a little bit of just a small amount of concrete, and you can have bricks that are rated for California seismic loads. And then these bricks, we actually think we can sort of sell the bricks for like 10 cents a brick or something like that. And they're really great bricks. They build houses with them and things. These way better than cinder block, because cinder block's kind of not that strong and kind of rough and grainy. These are super strong. They're more like I don't know what
smooth.
material. They're incredibly
smooth,
smooth. Yeah. There's not really a good analog for these, because these are bricks that are way better than any bricks I've ever seen at a construction site.
Yeah.
That they're capable of taking extremely high loads.
Yeah.
And they're made at 5,000 psi or something.
Yeah, no, they have higher compressive strength than concrete, and you can always just keep pumping it up more, just based on the machine.
Yeah, so higher compressive strength than concrete, and then we're going to do some fun things like make life-size Lego kits with where you can order a set and build, anything. I think we were thinking of starting with the Egyptian pantheon, and so you could
you told us to build a pyramid. We're building a pyramid and a temple for you.
Cool.
Yeah.
Temple of Horus. Okay, so start with the Temple of Horus. Pyramid and a Sphinx,
Yep.
And a few other things, and then if you want, you can sort of order the kit and kind of build this in your backyard, and it seems like a fun way to spend an afternoon. So then if we can actually take the dirt from the tunnel and instead of just dumping it somewhere, we can turn it into something useful that can be used for fun or for real buildings. I think this could be, for affordable housing, really compelling. Yeah.
Yeah.
So.
And if you look at the cost of a tunnel, about 15 to 20% of the cost of a tunnel is muck removal. It's just putting it in trucks and sending it to a fill. So if you do something useful and actually make a brick, even if you give away the brick, you've just cut the cost of tunneling by 15 to 20%, which is pretty great. And then one other thing to note on the costs is The cost to build a highway, I mean, it depends who you ask, but it's between 1 and 4 million a mile. So if tunnels were,
Is it per lane mile?
well, yeah, no,
Yeah.
it's like, yeah, add a lane,
Right.
add a lane, 1 to 4 million.
Yeah.
So, if tunnels were there, what, why is everything not tunnels in that case?
Right.
Yeah, so, okay. So everything.
Well, this would be a lot of like road space. If this works out, there would be a lot of road space that could be converted into sort of park space.
Yeah.
Yeah. So this what gives you a sense for like you really need a very small footprint to enter the tunnel network. It's like not much bigger than a parking space, and then you can interleave these entrances and exits throughout the city. Um, So, in some ways, this would be like a car in that it's really personalized mass transit, and you have, unlike a traditional subway, you have a highway system and a kind of like a series of off ramps. So when you're going through the tunnel network, you would enter the main arteries and then automatically transition from one artery to another, and then eventually go out through one of the little sort of micro stations, if you will, or mini stations, you'd be going very fast the whole time, and the only time you'd actually stop would be when you exit. And the thing about, say, a subway or a bus is that, or particularly a subway, subways usually stop at every station. You might occasionally have an express, but obviously one subway train can't go past another subway train. Very difficult. And so a subway ends up being like a series of stop streets, whereas this system is designed to be more like you have a highway and a bunch of off-ramps and loops connecting to the highway, kind of like cars. It's sort of like, almost like an autonomous underground multi-level car system.
That costs $1.
That costs $1, yeah, exactly. So we think we can probably just charge about $1 a ticket or something like that. A typical bus ticket, I think average price bus ticket is about $2. So it'd be like less than a bus ticket.
Yeah, and just in Los Angeles, I mean, if you kind of just do it out with the available routes, it would be like downtown Los Angeles to a specific terminal in LAX in about 8 minutes, which would be wonderful. And what's kind of neat about it, it's not just downtown LA to LAX. It's downtown, because the stations can be small,
Yeah.
It's downtown LA to LAX Terminal 1, LAX Terminal 2, and you would go directly there is the entire concept.
Yeah, I mean, this is sort of just route like packets on a network, on like sort of like the internet, kind of like the way the internet works. And the packet would like, you sort of end up wherever you want to be. And like, the entrance would be very close to where you want it to be, and the exit would be very close to where you want it to be, because instead of having dozens of stations, you'd have hundreds and possibly thousands over time. So it means the granularity of each station is much finer, and people can be dropped off really within a few blocks of where they need to go.
Yeah, and each side tunnel itself could have a bunch of side tunnels, so you
Yeah.
literally, I mean, in the extreme, you could have a station in everyone's driveway.
Yeah,
That's
that's sort of in the limit, yeah, absolutely.
Yeah.
So yeah, we should show the, all right. And then going between cities, you'd want to evacuate the air and have a pressurized pod. Now, what we're talking about doing here in LA is not the Hyperloop, but we're talking about a loop. So we're trying to distinguish loop versus Hyperloop. Hyperloop would be where we draw a vacuum on the tunnel, have a pressurized pod, and go very fast. And this would be good for long distances, say going from LA to San Francisco, going from Washington, D.C. to New York, that kind of thing. And so Hyperloop would connect to a loop, and you'd have a sort of smooth transition. Yeah.
Do you want to give the warning about the video?
Oh, the next video, if you subject to seizures, I would not look at this. So that was a video of a test pod ride that we did in the Hyperloop tunnel. So we have like a roughly 0.8 mile vacuum tube at just by SpaceX. It's about 5 or 6 feet in diameter, and we've been able to go a couple hundred miles an hour, and we think probably. We're aiming for around to go over 300 miles an hour, but accelerate all the way to 300 miles an hour and brake, and that's in a vacuum tunnel. So it's really just sort of refining the technology necessary for ultra high speed transport from city to city, and yeah, it's kind of fun. We can go faster than a jet. Like you don't really have. Sort of Mach problems, you're not creating like massive sonic booms because you evacuated the air.
There's no upper limit based on physics. It's just how straight is the tunnel to make the ride comfortable.
Exactly.
Yeah.
It's essentially constrained by the G loading that would be comfortable for a person in the tunnel.
And one of the wonderful events that Elon puts on at SpaceX and the Boring Company is a Hyperloop competition, which we do every year. And the first year, actually, this is true, over 1,000 universities worldwide entered, which was amazing. And then we narrowed it down to 20, and then 20 came and actually competed at SpaceX. Fastest pod wins. And last year, a team won at 202 miles an hour. That's a student team building a pod in 9 months. So it shows the tech is very doable.
Yeah.
Yeah.
Like so, and this is all running in a vacuum tube.
Yep.
So, while Steve sort of the credit, by the way, for the Hyperloop competition, really Steve deserves the credit. Steve really is the guy who made that competition happen and who runs it. So, thank you for doing that.
Thanks for letting us do it.
All right. All right, so what we're aiming for with this tunnel is a north-south tunnel parallel to the 405, and it's really intended to learn more about what it takes to build a tunnel on the sort of north-south geology of Los Angeles. Los Angeles is like New York is for like plays. If you can build a tunnel in if you can succeed in building tunnels here, man, because we've got seismic, we've got the water table, you've got like very complicated
utilities everywhere.
Yeah, utilities everywhere. So it's a very very complex thing, and we have an east-west tunnel that's almost completed in Hawthorne. That's parallel to the 105. So we have an east-west kind of research or test tunnel, and we think it would be good to have a north-south one as well. So we're going to have a good cross-section of the geology in LA. And then besides building the tunnel itself, we want to sort of see what the user experience is going to be like and what the public would prefer the tunnel operation to be like. So if you, what feels good, get public feedback by having people use the tunnel. We wouldn't be charging on what people would like or not like. Yeah, so the people will be wondering, like, well, how is this going to affect me? And the important thing is that there'll be no street closures. We're not tunneling beneath any homes or businesses. if anyone can detect that we're digging a tunnel, we'd be glad to hire them because they have some very impressive detection equipment. Literally, walking on the surface creates more vibration than the tunnel boring machine. It's really quite difficult to detect when a tunnel is being dug.
Yeah, and it's important. Like with this test tunnel, the community, and it's our goal. And if we ever don't, please let us know that nobody knows we're there, because it's really important that if we want to build very long tunnels from LA to San Fran, it's important to be an amazing neighbor, and that you don't disturb anyone. So this is, in our mind, you won't hear us, you won't see us, you won't feel us, you won't even know we even exist. The only way you'll know we exist is the fact that there are trucks on the road, and that was what the haul route hearing had been. And then so that's that's the haul route we were given. For those who are curious the direction, it's south on Sepulveda, east on National, onto the I-10 East. And then our trucks were limited, especially during rush hour, and we're not allowed to truck before 8 a.m. and 6 p.m. The concept being, we are going to do everything right. We're going to be the best possible community member, and if anyone has suggestions, please let us know. But the goal is that literally, we're invisible, and it's really, really important.
Yeah, absolutely.
Yeah.
It's obviously, in fact, this is really important because it's not going to scale if the creation of the tunnel, if we had to, say, a 2-mile tunnel without disturbing people, then how could we do hundreds of miles of tunnels without disturbing people? So this really needs to be something that people just don't even know it's there unless they look for it. And even then it's tricky. So, and then like I said, once we're done, we want to, in order to get public feedback, we want to sort of offer free rides, and it'll be like, sort of like a weird little Disney ride in the middle of LA. But I think we can make it really fun. Bring your flamethrower. Yeah.
Yeah, he's got a good point. It's not a flamethrower.
Oh, it's all right. keep making that mistake. All right, so we're working closely with the city of LA and with Metro to make this happen. So, yeah, sometimes people wonder, like, hey, are they just going and building this crazy tunnel and nobody is even looking at it, and they're seeking like exemption from all oversight? This is not the case. There are a zillion permits that need to be approved for this tunnel. So there's a huge number of city permits, county permits, state permits. The nature of the exemption that we are seeking is simply from CEQA, because getting a CEQA approval can take sometimes a year or sometimes 2 years. And we need to figure out what the large network will be, and use this sort of kind of research tunnel to figure that out, and then apply for the larger environmental or submit the larger environmental impact report to the state of California, which has the most stringent environmental rules in the country, maybe the world, but certainly, yeah, like probably the world.
Yeah.
And the nature of CEQA is that it's very much a permission-based system that takes a long time. So this would be a very safe tunnel, and would still fall within all of the permitting requirements that LA would normally require, which is I think something like 600 pages of permits that are required for this tunnel. So it's not like, here, fill in this form.
Yeah.
This is like 600 pages, at least, maybe more.
Our CEQA study alone actually was 1,500 pages.
1,500,
Yeah.
wow.
Yeah, and actually,
So we have done the CEQA study.
yeah, so the way, just for everyone
important to bear in
knows,
mind.
for CEQA to work is you don't just, it's not like we said, oh, we want an exemption. No, what you do an initial study, and then the initial study determines your next steps. And so, I mean, like we were talking about, literally there's no environmental impact. And so we did this 1,500-page study, submitted the study, and then the city of LA determined that an exemption was appropriate. But the main thing is, it's not being done to be controversial. It was the result of the study, and we're always going to do the right thing. We're always going to do, and so we'll keep working with the city and kind of go with that. But yeah, there are an enormous amount of permits, and then for a larger system, I mean, to be frank, we don't right now know what that system would be, because we need such an enormous amount of community feedback, and to know, because Elon's always very clear with me and the team, we must do the most useful, helpful thing possible. And I don't think we yet know what that correct alignment is yet, and we can't wait to get feedback on what it is. And then, yeah, then we go through a full EIR and go for it. But right now, the goal is really that test tunnel. And then with the metro has been wonderful, and our goal is to complement the metro as much as possible. One thing we do talk about is, and this is just us, is that the purple line's amazing, the Expo line's amazing. It would be neat to connect them. 2-minute trip, which would be really, really interesting. And so, just thanks to the metro for their support.
Yeah, absolutely. So yeah, we feel like we just reinforce what Steve is saying. We want to connect with and supplement existing transport systems. So if we do things like help connect 2 subway lines in LA, that'd be great. If obviously having us sort of like many stations come out at subway stations, at bus stops, at LAX and Dodger Stadium and various other places, that's going to make a lot of sense. We're trying to maximize the usefulness of this system while having it not be not affect people's lives as it gets created.
Yeah, it's pretty great.
Mean, so we think these times are actually real, which is pretty cool. And this is what you're seeing there is just like a kind of an example network. Ultimately, it would probably be something different from this exact diagram, and probably be far more widespread. Maybe like really all over the greater LA area. Yeah. So, but because of the nature of tunnels, as I was saying, you can, as you reach capacity on one tunnel, you can simply put another tunnel underneath it, and then keep going. And even if you want to have 100 levels deep, you could do 100 levels deep.
Which also addresses the induced demand, because unless everyone in the entire planet moved to LA.
Right. We're pretty sure everyone is not going to move to LA.
Yeah. I mean, yeah.
Not all at once.
Yeah.
And there's, we should have like a few stations would be bigger, like maybe at LAX, where you've got a single port, like an airport or a seaport. You'd see a larger station, and then those would all go and drop people off very close to their home or work.
Yeah, it's really based on land availability, right? If you're in a very urban area, you make small stations. If you're you can make larger others.
Yeah. So
that's a lot of questions.
I think there's also a bunch of questions that we'll have, I think, from the audience and from social media and that kind of thing. But these are commonly the questions that we will get. Is like, will we run into utilities? No, because we are below the utilities. So the depth of the tunnel is below all of the plumbing and utilities. Once you get below about 20 or 30 feet, there's almost nothing.
Yeah.
There's not even, no moles or sort of very few earthworms. Like it's just rock, basically.
A cool rule of thumb is that if you're 2 tunnel diameters below the surface, noise and vibe are imperceptible. So our boring diameter is 14 feet, so times 2 is 28. We usually round up to 30, and so we're pretty much always a minimum of 30 feet below the surface. Sometimes 40, sometimes 50, but always a minimum of 30, just so we don't disturb anyone.
Yeah, it's whatever the depth is that's necessary to ensure that we do not run into anything. Yeah. And then we'll be using the test tunnels for public transit. We'll be using them to get feedback from the public and figure out how to make it an amazing experience. And I guess technically somebody could go from you would start off in one place and end up in another. But it would be more for interest's sake that I think people would take it.
Yeah.
As opposed
and to give us feedback.
Yeah, exactly, give us feedback. Yeah. So we're prioritizing, so the commitment we've made is like we're always going to prioritize pods that carry pedestrians and cyclists. That'll be nice sort of higher density pod. And yeah, seems like that's probably the right thing to do. And then earthquakes is probably the single biggest question we get. And people don't realize that like earthquakes are primarily a surface phenomenon. They're like waves on the ocean. And if you're in a tunnel, it's like being in a submarine on the ocean. There could be a hurricane on the surface, but in the submarine, everything is quiet and smooth. And that's actually how it is for tunnels. And when there have been major earthquakes, such as there was a Mexico City earthquake, I believe, they used the tunnels for evacuation. Because all the roads were disrupted. And
the two cool factoids about the earthquake, the safest place to be in an earthquake is in a tunnel.
Yeah.
And so LA was just hit with I think it was 5.3 or 5.6 earthquake, and our office trailers were rocked, as I assume everyone else was, and the people in the tunnel who were working did not know an earthquake had occurred. And a way to think about it from a physical standpoint is if a tsunami hits you, where do you want to be?
Yeah.
You don't want to be at the surface. You want to be, if you somehow could be, at the bottom of the ocean where you would not feel it at all. So no, it's a very big misconception, but earthquakes, and they're designed for seismic loading is standard for any tunnel design, especially in this area. Metro does it, we do it.
yeah, it wouldn't be possible to have a subway tunnel in LA,
Exactly.
which a lot of people do not realize exists, but there is a subway in LA.
Yeah.
But it would not, if earthquakes were dangerous, there's no way that a subway in LA would be approved.
Yeah. Same with Japan.
Yeah,
Lots of subways.
Absolutely.
Yeah.
Exactly. Japan is very seismically active and has one of the best subways in the world.
Yeah.
Sinkholes, yeah, I think would we agree that if you could actually detect with any instrument, detect that there's been a ground movement, we will take corrective action and then ask you for what that instrument was. Because it's really, there will be no change in, no sinkholes, no nothing.
Yeah, and we actually, if you're ever driving on 120th Street in Hawthorne, you'll see these little prisms on the road. And we actually put them there, and we have an autonomous system monitoring the settlement of the road. And if it ever goes above a 20th of an inch, which I think it maybe has happened, it might even be 0 times, it almost never happens, the entire company gets an email and people stop. So we overlook at this because obviously that would be something that would not be good. So we monitor this and very closely, as the LA Metro do the same thing, and we've seen great numbers. I mean,
it has zero effect. It's
it does.
Essentially, you dig the tunnel, you put in super strong reinforcing segments, and those maintain the diameter that you've cut out of the ground, and there's no volume change. And so as a result, sinkholes are not a factor.
Yeah.
Our tunnels will just basically go below the metro tunnels, so there will not be any interference with the LA subway system. Talked about CEQA. We absolutely will be doing an environmental impact report for the larger system. And we have, as Steve was saying, done a very comprehensive report in the request for exemption.
Which is public, it's online.
Yeah, this is like good bedtime reading. 1,600 pages?
It's between 15 and 16, yeah.
Yeah. Okay. This is, so, we think it's probably a fair thing to do, and it will allow us to get this done sooner than might otherwise be the case, because we can resolve a lot of questions with essentially the research and public feedback tunnels. Yeah. And then we talked about induced demand.
Cool. So.
And we sort of use, a lot of people that are at the Boring Company are ex-SpaceX or even current SpaceX people. Like Steve is one of the first people to join SpaceX. It's like,
thank you for the job.
Well, you're welcome. Like
2003.
Wow, 2003, damn.
Number 9 right now.
Wow. Okay. Well, thanks for everything you've done.
You're number 3, I believe.
What the? So yeah, we have a lot of SpaceX engineers that are either kind of working at SpaceX and the Boring Company or full-time at the Boring Company. And so we get to use rocket technology to build tunnels and apply some pretty advanced techniques to tunnel technology, which hasn't generally gotten a lot of love. So we're really taking world-class engineering talent, applying it to this problem, and seeing if we can make some headway. And at SpaceX, we were able to go from basically an empty warehouse in El Segundo in 2003 to the Falcon Heavy launch this year. We were able to land 2 boosters at Cape Canaveral. The center port hit the ocean, but we know how to solve that. And then as a demonstration, sent my old Roadster to the asteroid belt. And it's like more interesting than launching a block of concrete. We did that because, like, normally when rocket companies launch something, they launch something boring like a block of concrete. And like, what's the least boring thing we could do? And ironically, boring. So I think if a team of people who did what you saw there, then if some of those resources were applied to personalized mass transit, then there's the potential for significant breakthrough. But obviously that can only happen with public support, and so hope that if we can ask for your support, that would be great. I really appreciate it. All right, so yeah, I'd really like to thank everyone involved. I've worked with the cities a lot, Councilmember Kretz in particular, community members, the Temple, and LA Metro, and we're really trying to make sure all the stakeholders are involved, and that we get as much feedback as possible, and do something that is useful, and ultimately may delight those who use it. So,
Thanks.
Are there more questions that we should answer?
I think.
Okay.
There we go.
So I know we addressed a lot of the frequently asked questions, but when you guys came in tonight, you guys submitted some question cards as well as utilize our interactive Q&A platform. So the questions that you submitted have been voted, and the ones that voted, rose to the top. We'll address those now. First question. What engineering challenges are you expecting from drilling underwater, and are you considering using immersed tube tunnels?
Yeah, actually, the tunnels are, I believe, water and gas-proof too. Well, Jen, why don't you answer this?
Our alignment in Los Angeles
you might
is
need to
actually
move the mic closer.
our alignment in Los Angeles is actually above the water table, so we won't be tunneling underwater in LA,
But we can.
But we can, exactly.
But, and really, the gas permeability is a bigger issue than water.
Right.
Because you have to be gas impermeable to roughly 5 atmospheres.
And I would just add that, our tunnels are sealed to, water and air, so,
Yeah.
Looking long term, Hyperloop, the whole concept of Hyperloop is keeping a seal. So we've obviously designed from day one for that, and that includes water, methane, and just all air. So, it's really a sealing exercise, which I think we've done pretty well with.
Yeah, it seems like if you have a tunnel that is capable of holding 5 atmospheres of pressure, then if you draw a vacuum on that, you've only subtracted 1 atmosphere. So as long as your system has a very low leak rate, you can maintain a vacuum and still have 4 atmospheres of compressive resistance.
So we'll take it to one of the question cards. You guys addressed this a little bit, but how much would it cost to travel from LAX to Sherman Oaks?
Well, I think it was like $1.
$1, yeah.
Yeah. What is an immersed tube tunnel? Do you guys know?
Another question we got from
go ahead.
from Slido is utilities. You touched on this. How far beneath are we for the utilities?
Yeah, we're way beneath the utilities. We'll essentially clear the utilities by at least 20 or 30 feet at the very lowest end. So, If we need to, we'll just go as low as we need to. We will go lower if we need to. But we could go hundreds of feet underground. That's no problem.
Yeah, it's generally the answer is just always go deeper. You pull the as-built, you see where the utilities are, and you design to make sure you're so far below them that they just don't care.
Yeah.
Yeah.
When are we going to get our flamethrowers? Our not a flamethrowers?
I was hoping you wouldn't ask that question. We're working, actually, I think quite soon. So we encountered some delivery challenges where I guess like they don't like it if you like ship things with propane. So
We've got a solution.
we have a solution, which is custom delivery to your house or business with a boring company delivery van.
Me and Jen are going to show up at your house. This is true, with a flamethrower.
Yeah.
Yep.
Except not a flamethrower.
Personal
sorry.
delivery.
Yeah.
Yeah, we're just going to deliver it to you. We're just going to get some vans and people and deliver it to you.
Yeah.
Yeah.
Starts in 2 weeks.
Yeah, so we're starting deliveries in 2 weeks.
Yep.
Yeah.
All right, what lessons did we learn from modifying Godot that we're able to apply to Linestorm?
Wow, there's a ton.
A lot.
Yeah, I mean, with Godot, which is the name of the first machine, Godot is a conventional, essentially a conventional tunnel boring machine, and we did not know how to dig tunnels at all, actually. And we're like, wow, what is involved in digging a tunnel? What permits are required? What are the engineering challenges? And so Godot was all about, obviously, a lot of waiting and like figuring things out. So going from Godot to Linestorm, Linestorm is a modified, highly modified, conventional boring machine. But it's essentially a hybrid between a conventional boring machine and then proof rock, which is the fully boring company designed machine. So proof rock, that'll be quite a radical change. Like proof rock will be, we think, probably about 10 times, aspirationally 15 times faster than current boring machines, aspirationally. But I think very likely 10 times. And then Linestorm would be hopefully 3 or 4 times, but I think at least 2 or 3 times faster than current boring machines as a hybrid solution. The main thing to do with Linestorm is to automate the segment direction and to be able to keep modifying it to where we can do continuous drilling and segment direction. So there's a lot more automation. There's a lot more, yeah. I mean, yeah. It's. I mean, these things are.
The pit as well, the automated pit on the other side.
Yeah. Like a lot of these things, like they're like really simple. Like they're not. It's just like not rocket science. Like we really need to get the dirt out fast. So. It's not actually the tunnel boring machine that, for example, is an issue there, but you need 2 lanes so that you're not going all the way into the tunnel, getting a bunch of dirt, and then going all the way out. You want to be able to cross. And so being able to have a place where we can switch, where there's like a passing lane, essentially, so you can bring tunnel reinforcing segments in and dirt out at the same time. That's actually quite a huge thing. Like that alone would be probably a doubling or tripling of boring machine speed.
Yeah.
Like a lot of these things are really quite boring. It's like, well, what about a passing lane? Yeah, sure. Okay, let's do that. Okay.
Yeah, between the passing lane, the fast muck dump, and the automated segment director, that should be a tripling of speed.
Yeah.
Yeah.
Where will the entrance and exit systems be, and won't they create a line causing even more traffic?
Yeah, so where will the entrances and exits be, and won't that cause traffic where the entrances and exits are? The reason we think that will not cause traffic is that there will be a very large number of entrances and exits, all of which are quite small. And so they'd be the size of a parking space or a few parking spaces, and there'd be many of them, and they'd be woven throughout the fabric of a city. So instead of having a small number of stations like a subway, which would then dump out a huge number of people all at once, and that does create a localized traffic jam, this would have dozens or hundreds of stations that would only put a small number of people out at each station and not create a traffic jam where people at each point, because we're not concentrating the entrance and exit of the passengers.
Yeah, 16 people get out.
Yeah,
And that's,
like how much
Yeah.
traffic can 16 people create? And that's sort of maximum. I think probably most of the time it'll be fewer than that.
yeah.
A couple more questions?
Sure. I mean, if they're, yeah, sure.
It's a good question.
I don't know, I get like a lot of flack these days for questions.
All right. Would the Boring Company be willing to do a full EIR?
Yeah, totally. We're definitely going to do a full EIR for a much larger system. It'll just take us a while to formulate that EIR and then submit it for approval to the state, and then it takes a while for the state to digest that and provide the approval. We don't expect there to be any issues with the EIR. It's just something that takes a lot of time to do. And we want to make sure that the EIR is informed by these research tunnels, so that we submit the ideally most correct EIR that we can.
Yeah, exactly. An EIR is a big deal, and we want to do it, and it takes over a year or 2 years, whatever the number is. So you want to make sure when you go into that, you know exactly what you are going to build, and it is the most useful thing. And we don't have that knowledge today, and that's why we're looking for feedback and going out to the public, because we want to be sure when we do it that it is the right system.
Yeah.
Great. And this will be our last question. This came from a question card. Will you organize a big party before the tunnel launch?
Of course. Yes. I was thinking, like, this would be like a really trippy place to throw a party, you know, 'cause, like, but it'd be like really fun and like feel like, I don't know, like pre-post-apocalyptic or something. You know? Yeah. It's so bizarre. But I think partying in a tunnel would be kind of fun.
Yeah, I think so too. You're on
Yeah.
record saying it, so
Yeah.
yeah, it's got to happen.
Absolutely.
All right.
All right. Thanks, everyone.
Yeah.
Yeah.